Okay, so we are starting section 9.2, notes for exponential functions. An exponential function where the independent function appears in an exponent. So remember, your independent is your x's, okay? Just like domain and range, domain is your x, independence are x. So your x is going to be an exponent. So this is similar to what the equation for an exponential function will look like. And remember, f of x just means y. Okay, so don't let that confuse you. So that's just y equals a and b will be numbers, and then x has to be an exponent. Okay, for example 1, evaluating an exponential function, they are giving you an equation. So f of x equals 2 times 3 to the x power. Models an insect population after x amount of days. X, represents your days. What will the population be on the 5th day? So they're telling you how many days they want. So they want you to plug this in for x. And then we're just going to use the calculator. Okay, so I'm going to have 2 times 3, and then I'm going to change the x to a 5. So that is what I'm going to plug in the calculator. So on my calculator, clear that out. So I have 2 times 3, hit your exponent button, remember that's the up arrow, to the 5th power. And we're just going to hit enter, and it's 486. So 486 will be that population on the 5th day. Okay, right below that, to be an exponential function, the x values, and we're talking about for a set of numbers, the x values must have a constant pattern by adding or subtracting, and that's been the same way the whole time we've been doing these patterns. But the y values are the ones that are different. The y values must be multiplied or divided to get the next number. Okay, so looking down here at example 2. So on A, if you look at your x values, they just have to have a pattern, and again, it's adding and subtracting for the x's. And if you notice, they are all adding 1 each time. Okay, but for the y values, it has to be multiplying or dividing. So to get from 1.5 to 3, well, I'm not sure in my head what that is, but I know 3 times 2 is 6, and 6 times 2 is 12. So on my calculator, I'm just going to make sure 1.5 times 2, does that give me 3? And it does, if you look at the calculator. Okay, so all of these are times 2. So it says, tell whether the set of ordered pairs satisfies an exponential function, and your answer will be yes. And you do not have to tell me why, as long as you show the patterns. Okay, if we move down to part B. So if you look at your x's from -1 to 1, so that goes from -1 to 0 to 1, it's plus 2. 1 to 3 is plus 2. And then 3 to 5 is plus 2. Okay, but to get from a -9 to a +9, you're multiplying by a -1. And remember, I'm not checking, adding, or subtracting on these because remember, it has to be multiplying or dividing only. To get from 9 to 27, I know that is times 3. So since those two are different, this one is no. It is not exponential. Okay, so that's example 1 and example 2 from 9.2. Okay, we're going to finish example 3 from section 9.2, exponential functions. I'm just going to do B and C from example 3. I'm pretty sure you'll get the hang of it after those two. But those are the harder ones to do. So first thing, all you have to do is you make a table. So just a regular XY table that we're used to. And you have to pick your values for your X. So I'm just picking the normal ones that we always pick. So -2, -1, 0, 1, and 2. Remember, you should always pick some negatives and some positives if you're choosing different numbers. Okay, the next thing I'm going to do, I'm just going to plug those numbers into my equation for the X. Okay, so if you do that, this is what the first one will look like. So -5 times 2, and then the X is changing to the number that I'm plugging in, which is a -2. Okay, and I'm just going to plug that in the calculator. So I have -5, parentheses 2, and then I'm going to use my exponent button. Remember, it's the up arrow. And then type in -2, hit enter, and it's a negative 1.25. If you wanted to round that to negative 1.3, that's fine. Okay, and all I'm going to do, I'm just going to arrow up, scroll over, and I'm going to change my negative 2 to a negative 1 because that's the next number I'm plugging in. So it gave me a negative 2.5. I'm going to scroll up again, change that to a 0. I get negative 5. Scroll up again, 1. It's negative 10. And then one more time, change that to a 2, and I get negative 20. Now I'm not going to plot the negative 20 on this graph because this graph only goes to negative 10. So the extremely large number, you can just leave that off your graph. You'll still be able to see the shape. Okay, next I'm just going to graph each point. So negative 2, negative 1.25, which is just below negative 1. Negative 1, negative 2.5, 0, negative 5. And then 1, negative 10. Okay, if you notice it's slightly curving, and it's always going to approach the x-axis, but it never will cross it. So you have to make sure your line, it will approach that x-axis, but it should never go above the x-axis in this case. If my curve was on top, then it should never go below. Okay, but that's the shape for an exponential function. So remember, linear was lines, quadratic was U-shape, and then the absolute values with the vars, those were V-shapes. So this is the last shape we learned for this class. Okay, I'm going to go ahead and do C. If you feel like you're comfortable, you can stop listening now. But if you want one more, I am going to do C just to make sure we got this down. Okay, so again for C, I'm just going to make a table. I'm going to use the same numbers. I'm going to use my calculator. So again, I'm replacing this X with those numbers that I picked. So I'm going to clear that. So I'm going to do 4. I'm going to use the fraction button since it's a fraction. And I'm going to start with a negative 2. So that gives me a 64. I'm going to scroll up. Negative 1. 16. Up. Change it to 0. It's a 4. Up. 1 is 1. And last one. 2 is 1/4. And 1/4 is the same thing as 0.25. If you didn't know that, all you have to do is do 1 divided by 4 in your calculator and see it'll change it to a decimal for you. Okay, I'm just going to graph these. So obviously 64 and 16 are going to be way off the graph, so I'm just going to graph the other three. So 0, 4, 1, 2, 3, 4, 1, 1, and then 2.25 is really close. So it's going to look similar to this one, except for this one's on top this time. So it's going to be curving. But again, when it approaches the x-axis, it's not going to cross it. So it just goes right along with the x-axis. Okay? The bigger numbers I put in here, it's just going to be smaller decimal, smaller decimal, smaller decimal. It'll never be exactly 0. So that's why it looks like this. It just approaches it. It should never go across the x-axis. And that's how you graph exponential functions.